Welcome to part 2 of my series, Learning Machine Learning So You Don't Have to. If you haven't seen part 1 already, please watch it. So today we're going to be working with a very popular dataset. It's called the iris dataset. It's essentially a dataset of different irises, which are plants. It has different measurements of the plants. It has the sepal length, sepal width, petal width, and then the species of the of the plant. And we're going to be using supervised learning to train a model on the data so that it's able to get measurements and predict what species it is. So let's just look at the code. So here I'm just loading the basic packages. Here I'm just loading the dataset. It's in a file called iris.csv. Here I'm just loading it. So the first step before doing any machine learning prediction or training model is to do explanatory analysis, which is basically looking at your data. So if we look at the columns in our data, we can see that it has ID, sepal length centimeters, sepal width centimeters, petal length centimeters, and petal width centimeters. It also has a species column. So let's look at the first 5 rows of our data set. I'm just using head. We can see that these are the first 5 rows, the measurements. Then you can see that it says the species we're looking at here is Setosa. And then now I'm really interested to see what species we have in this data set. For that, I can just do the name of the column like this. And then I can use the unique function, which basically looks at the pandas column and looks at the main set of plants which are in the column. You can see that we have Setosa, Versicolor, and Virginica. Sorry if I've butchered those. So that's our target variable, or what we're going to be trying to predict. And then now we're just looking at the statistics of our data set. And what's interesting is the count is 150 for all of them. And you can see the different maxes here, which is interesting. You can see the mean and the different percentiles. And then now let's look at the shape of the data. Shape basically gives us the number of rows and the number of columns. You can see that the number of rows are 150, which basically goes with what we saw up here, which shows you that we have no NA values or NaN values or null values in the data. Let's briefly talk about training and testing. When doing machine learning, we want a machine learning model that works on new unseen data, not just data it has already seen. We cannot test a model using the same data we trained it on, because it might just memorize the answers. Memorizing training does not mean the model is actually smart or reliable. How do we check if a model works? We have to split our data into 2 parts. Training data, which is used to test the model, and testing data, which is used to check how well the model performs on new data. Why does this matter? Good performance on test data shows the model can generalize, which means make good predictions on new data. And on our next part of the series, we're going to be looking at the scikit-learn train_test split function, which basically shuffles the data and splits it into different variations based on how we want to split. Also, the last thing I want to say before we finish up with this part or episode is that rubbish in means rubbish out. If you give your model bad data, which is rubbish, your model is going to be rubbish as well.